Let me work out a problem involving echelon forms. Suppose that we have the following system. Let the system x plus y plus z equals 4, 2x minus 2y plus 3z equals 6, 3x minus y plus 5z equals 5. And suppose that we want to find the echelon form of this system. So let's find the echelon form for this system. So this means that we're looking for a form that has the echelon shape, like a descending staircase. That means that in this case, we want something whose first coefficient in x is non-zero, whose coefficient in y in the second equation is non-zero, but the x is not present, and then whose coefficient in z is non-zero, but the x and the y are not present, following these echelons over here. So what we're going to do, so I'm going to label these equations as equation 1, equation 2, and equation 3, just to keep organized. And I'm going to try to get rid of this two parts over here. I want to get rid of those so I can have that echelon part. So one thing that we can do is, let me think about the third equation minus the sum of the first two. And I'm trying to do that because I realize that if I add the first two equations, and if I look at the x coefficient, that actually is enough to cancel, to get rid of this coefficient over here in the third equation. So that's why I'm looking for adding the first two equations and then subtracting the third one from that. So in this case, what I have is, I'm going to write down the third equation, which is 3x minus y plus 5z equals 5. And then the sum of the first two, that would be x plus 2x, that gives me 3x, y minus 2y, that gives me negative y, and then z plus 3z, that gives me 4z. This equals 10. Now, if I perform this subtraction, then what we get is that the first two would cancel, then the y's will also cancel, and then the remaining would be just z equals negative 5. So in other words, that means that I can replace the third equation by this new equation. So I get that my new system of equations is going to be the first equation, which was x plus y plus z, x plus y plus z equals to 4. I have the second equation, I will leave it the same way, which is 2x minus 2y plus 3z, 2x minus 2y plus 3z equals 6. And then the third equation will be a new one. It will be the one that I got in here. So this will be just z equals negative 5. And do you see that we are starting to look that echelon shape that we're aiming for? Now it seems that this echelon right here is too wide. So that means that we need to improve it a little bit more, and we need to get rid of some stuff here in the front. If we can do that, then we are in good shape. So in this case, what we have is that we can get rid of this guy, the first one, just by multiplying by 2 the first equation and subtracting to the second equation. That means that my next move, I'm proposing to do second equation minus 2 times the first equation. It seems that that will get rid of that first coefficient over there. So if I compute that, I'll get the following. The second equation, I'm going to put it on top. That is 2x minus 2y plus 3z equals 6. And then twice the first equation, that will give me 2x plus 2y plus 2z equals 8. Now we can subtract these two equations and we get rid of the first part, which is great. And then we end up with minus 4y. Remember, we're subtracting negative 2y minus 2y. That will give me negative 4y. And then we have plus z equals minus 2. So I can replace then the second equation by this new equation that I got. In other words, I get yet a new system of equations. The first one is going to be the same as before. So the first one is going to be x plus y plus z equals to 4. Same thing as before. But now the second equation is also going to change. And instead of having the second equation that I had before, we're going to replace it with this new second equation that we have. So that will give me negative 4y plus z equals negative 2. And then I'll keep my third new equation, which was just z equals negative 5. And now we can definitely see this echelon part that we were talking about. So our echelons are pretty nice in here. So remember that the main idea is that every time you move a step down, you need to also move to the right by at least 1 unit. That's what we call echelon part. Before, we didn't have an echelon in here because you see that whenever I move one down, I didn't move at all to the right. I actually had to move another space down, and then I move actually twice in here. So this is not really an echelon. This is not an acceptable echelon because my echelons are too big, my steps are too big. But in this case, this is a good echelon. Because every time I move one down, I move one to the right, one down, and at least one to the right. And this is the important part. Every step down, you should move at least, this is important, at least one step to the right. It can be more than one. It actually could be more than one, but at least it has to be one step to the right. So in this case, we care about this echelon part because this allows me to a very easy solution for this system of equations. Just as a bonus, I can actually solve the system of equations because I know already that z equals negative 5. Then if I substitute this into the second equation, into my 2 asterisk, then I can figure out what's the value for y. In this case, I know that y will be negative 2 minus z divided by negative 4 just by looking at the new second equation. And this gives me a value of negative 2 minus negative 5 divided by negative 4. This actually gives me, I believe, negative 3 over 4. So that's the value for y. And then once I have y and z, I can solve x from the first equation. That first equation gives me a solution for x. That'll be just 4 minus y minus z. So in this case, that will be 4 minus negative 3/4 minus negative 5. And this will give me, I believe, everything over 4. Probably is the best way to deal with this. So this will be 16 plus 3 plus 20. And this gives me a value of x of 39 over 4. So that's why we care about echelon forms, because this is a very systematic way for us to solve systems of equations. We don't have to figure out different strategies for every different system of equation.